Welcome to Kotlin Conf. 2 million developers use Kotlin for any task that you can imagine.
Google itself has been adopting Kotlin at a rapid pace. Last year, we told you we have over 15 million lines of code in our internal code base. This year, this has more than doubled to 33 million lines of code.
Today, I am thrilled to present the release of Kotlin 2.0. Kotlin 2.0 is a significant performance boost for daily productivity. It is future-ready, robust, and fast. Thanks to the new compiler, we can evolve the language much faster than before. The new compiler architecture by itself fixed many long-standing issues in the language. Kotlin 2.0 brings 2 times improvement in compilation speed. We see about 1.8 times improvements in code highlighting speed on the code base of IntelliJ Ultimate.
We are going to take a look at 4 language features that are set to be released first. Here we have a function that takes a parameter of the type status and returns a string. So what's wrong with this code? We repeated the status variable 4 times within the when expression. So we'd like to pull the variable out to avoid this repetition. And in Kotlin, one way to do this is to use when with subject construction. So let's try to do this now. If we do this, we get a compilation error that end is forbidden at this position, because using when expression with a subject has one important limitation. Each branch must have only a single check. So we are going to remove this limitation by introducing guarded conditions, where you can have additional conditions separated from the first check by if. Now let's take this particular part of JSON data and embed it into a multi-line string. As you can see, the JSON keys become unresolved references, since the $sign is used for interpolation. So we have to escape the $sign somehow. Well, let's just say that there are some quite tricky ones. The idea is if you put 2 $signs in front of a string literal, then interpolation must also start with 2 $signs. And a single $sign can be used just as a symbol. And the feature for multi-dollar interpolation also goes beta in Kotlin 2.1. In the next example, we iterate over a range of numbers, retrieve the state, and for the non-null state we check. If it's -1, we break from the loop. If it's 0, we continue. While the code looks correct, it won't compile. You see, we've used break and continue inside the function called let, which is forbidden. And the reason is that the compiler doesn't know anything about the function let or when its lambda will be executed. But let is an inline function, which means its lambda cannot be stored anywhere and must be executed in place right in the for loop. And this property makes inline functions truly transparent to jumps, making the use of break and continue absolutely valid. Now let's take a look at a feature that has naturally evolved in Kotlin over the past few years. The update is about context parameters or context receivers, which you've probably heard of. But first, let me briefly recap one of its use cases. Let's imagine I'd like to write a function without a clause that can automatically close all the open files in a lambda. To do so, I introduce the interface autoclose scope and 2 functions, with autoclose, which starts a new scope, and the function open, which can open files in such a scope. The issue here is that I'd like to define the function open as an extension on a file to make the API more extensible and friendlier to IDE, so that it will be possible to inspect available operations via autocompletion. But that's not possible, as the function open already has a receiver. And here is where context parameters are going to help us. Essentially, I am moving the extension receiver to special context parameters section. So now it's possible to define the function open as an extension on file and have a familiar and friendlier API. The feature was already released as experimental and became quite popular. So we are addressing your feedback and moving it to beta in Kotlin 2.2. We've discussed a portion of language features that are going to be released soon. And these features contribute to broader focus areas we find important, such as data recognition and deconstructions with improvements to our powerful data flow framework and data classes, increasing abstractions with such features as context parameters and explicit backing fields, high-performant and clear code with value classes and immutability, and, of course, library offers experience with improvements to opt-in mechanics and signature management.
Kotlin Multiplatform is officially supported by Google, and it's a recommended approach for sharing business logic across platforms. Last year, Kotlin Multiplatform went stable, but more is coming, starting with the integrations to the iOS ecosystem, which we are going to take on the next level with direct Kotlin to Swift export. This tool takes your shared Kotlin code, sources or libraries and translates its public API into idiomatic Swift code. Compose Multiplatform, our declarative framework for building cross-platform UIs, is already stable on Android and desktop, and iOS is moving forward quickly. Interactions feel more natural with changes to scroll physics and gestures. You have more common components available, and their interactions have been adjusted specifically for iOS. Compose iOS apps also become more accessible with out-of-the-box integrations with platform capabilities like VoiceOver. And the developer workflow improves with a new common DSL for testing UIs and better tooling support. We're also introducing new common APIs, addressing the needs of the community in the essential areas when building UI. And with our new common resources API, you are getting type-safe access to cross-platform assets and common code. With all these developments and additional under-the-hood changes, we are taking the next step on the road of stabilization, promoting Compose for iOS to beta. And with Compose Multiplatform for web, you can bring your app experiences with component-level reuse straight to the browser. It's powered by Kotlin for WebAssembly. Now you can port your Compose applications to the web and they will just work, looking and feeling as great as on our platforms. We are promoting Compose Multiplatform for web to alpha.
Beyond this, we're also thinking about the way you set up and configure your projects, which starts with the build tool. That is built with multi-platform support from day one, and that is built with tooling support in mind. And our answer to that question is Amper, our new build tool. With Amper, you can set up a simple Kotlin JVM project in just a single line of configuration. From there, adding new dependencies is just as simple. And for your multi-platform project, your configuration still stays just a few lines. Now, Amper is still in its early stage, but we do want to evolve it based on your feedback.
The AWS SDK already has support for Kotlin Common, but we will work on supporting targets beyond the JVM and Android, including iOS, macOS, Linux, and Windows. We're also working on adding a high-level API for Amazon DynamoDB object-to-data mapping. And another exciting API that we're working on is an Amazon S3 transfer manager, making it easier to handle transferring files between Amazon S3 and other systems. And finally, we're working on adding more telemetry integrations with systems like Amazon CloudWatch and AWS X-Ray.
Let's talk about Kotlin and AI. I also want to share that JetBrains AI Assistant is written entirely in Kotlin.
Thank you, Sveta. Thank you, everyone. I hope you've enjoyed the keynote.